Hi guys, BuildZoid here, and I just got back from a trip. There's also been like no videos for forever on the channel, so I think some low effort content is in order, and that will take the form of a first impressions of the various RTX 5080 PCBs, because I haven't really seen any of them. I mean, I've seen a couple, but I was looking at them on my phone, so I couldn't really see anything, so yeah. I'd say I haven't seen most RTX 5080 PCBs, and now we're going to take a look at them. So, obviously, big thank you to Tech Power Up for including high-res PCB pictures in their reviews. And with that out of the way, let's get into it. Starting off with the MSI RTX 5080 Vanguard SoC. I haven't seen this before, and this looks like the same PCB they have on the Supreme X. Because that's one of the ones I did see. Yeah, oh, it's not the Supreme X, it's the Supreme SOC. Okay, well, that's great. MSI appropriating Gigabyte naming schemes. Though, actually, I feel like MSI at one point had SOC. Or was it just OC? I'm not sure. Anyway, yeah, so this is the same PCB, and the only difference is that there's a power stage missing, which is not a very big difference. Yep. Yeah, well, I'm not. Yeah, the thing is, I can't even say that this is like a phase that's going missing because this power stage probably shares its PWM signal with this one, so they're like in one phase together. But yeah, that one's missing. So that's not really a substantial difference. So yeah, not really much to say here. I think we should have maybe started with the Founders Edition, so we had like a comparison point instead of just jumping straight into it. So, well, actually, yeah, I'll just keep the Founders Edition up and compare against that. Now, I do not like the Founders Edition PCBs. Well, I don't like the 5091 more so than the 5081, because the 5091 is just extremely running out of space. And I am not a fan of that. Like, it is very impressive that Nvidia managed to fit so much GPU on so very little PCB, but basically at the cost of everything else. Manufacturing cost, repairability, arguably reliability. This card doesn't do that, but the 5090 has like power delivery sitting directly behind the core, which I am not a fan of because power stages, even like the smart power stages from monolithic power systems, which these cards use, like sometimes these do technically have a bunch of extra safety features built in, but they do still have catastrophic failure modes. And if that happens behind the GPU core, that is a disaster. Though that is not a concern on the 5080 because, yeah, there's nothing, it's just capacitors behind the GPU core and a power connector for some part of the heatsink assembly. Yeah. Anyway, so in terms of power stages, we've got these monolithic power systems MP87993s. Now, these unfortunately don't have a public datasheet. As far as I know, they should be 50 amps. Which makes sense because they have this like smaller square package. And also these are on a GPU. This is one thing I find extremely funny is GPUs use realistically rated power stages because nobody cares about GPU power delivery. Whereas motherboards use unrealistic power delivery like power delivery ratings because it's a marketing thing. So, yeah. That's just like a funny difference between like motherboard VRM design and GPU VRM design, where GPUs have much more realistic nominal current ratings because nobody actually cares about GPU power delivery. At least not enough to put the like power stage current rating into the marketing materials. So anyway, as far as I know, these are 50s. And we're supposed to have, well, Tech Power Up did some of the work for me, so thanks. 15 phases. So this is going to be some wacky Like, it's not actually going to be a 15 phase. There's probably going to be like 7 phases with 2 power stages each, and then 1 phase with just 1 power stage. Yeah, that would actually make a lot of sense, because this is... Unless that monolithic power systems controller is also doing memory, but that's supposed to be handled by this chip over here, which is an adorable version of the MP2988. And so this is probably actually all 8 phases for the GPU. So plenty of current handling capacity. What are these? These are 100 nanohenry inductors. That's pretty low inductance. So those should be some really, really high current inductors. Of course, on the back of the board, we have the PCIe Gen 5 connector, then the display connector, the connector that likes to melt. That's actually one thing I'm really wondering about, is if like 5090s are going to like melt even more 12-volt high power connectors than 4090s did, because 5090s pull a lot more power, even in their stock configuration. So the thing I was looking for was, I was hoping to see the US 5650 somewhere, which is the shunt monitoring chip, but apparently it's on the front. Oh yeah, it's over here. So there's your shunt monitoring chip. What's funny about the US 5650 is it seems to be really inflexible. So every single card that uses it always has 4 shunt resistors, even when they're like there's only 2 power inputs on this board. There's a power input from the PCIe slot, and then there's the Melty connector. And that's it. So having 4 shunt resistors is kind of ridiculous, but as far as I know, that's actually a limitation of this chip, where it's like you have to have 4 shunts because this thing has 4 inputs, which is a bit weird. Anyway, so basic 59... Well, I wouldn't say this is a basic PCB, because in terms of capacitor configuration, this thing's kind of ridiculous. Like, look at all this ceramic. Like, that actually... Yeah, that is actually insane. I wonder why they did that. Because these are probably too far away from the GPU core to actually be beneficial. And the SMD polymers should be cheaper. So I kind of wonder why they did that. We have co-caps for the input filtering. So these are tantalum polymers from Kemet. And then the output capacitors look a hell of a lot like SP caps from Panasonic, but I'm not 100% certain. But I do think those might be SP caps, so those should be aluminum polymers. It doesn't really make a ton of sense to use tantalum polymers for output filtering, because you usually just end up with worse ESR. Whereas for input filtering, tantalum makes sense because you can get really high capacitance at like higher voltage ratings. But for low voltage, you can just use aluminum polymers instead in an SMD package. So from like a power delivery perspective, I like this PCB. Like, the filtering configuration is really cool. Like, well, really good. And the power stages are solid, and there's like a lot of them. What is it? 15. So that's what, like 500, 750 peak current output. Oh, that's an interesting BIOS chip over there. Yeah, Nvidia ran out of space on this board so hard that they even have like a special BIOS chip. Or, well, I mean, I don't know. No, I'd say it's special, because usually you see the like full-size 8-legged one. I mean, this is still 8-legged, but it's like way smaller. So that's a special BIOS chip, as far as I'm concerned. At least for a GPU. That's not in a laptop. I'd imagine laptop GPUs probably use the same thing. Other than that, we have a bunch of minor voltage regulators scattered around the board. Like over here, I'm assuming we have a 5-volt regulator for powering the power stages, because power stages run on 5 volts, and PCIe slots only provide 3.3 and 12. Though technically you can get some power stages that run on 3.3, but you don't really want to do that because there's not that much 3.3 volt power. Then over here we have what could be PEX, and maybe over here what could be 1.8. Maybe it's not labeled. I don't have one of these cards in hand, so it's not like I can measure this. We've got these two regulators over here, which I have no idea. Like, this could be more 5 volts. It could be something else as well, but yeah, I don't know. So yeah, that's the reference PC. Well, okay, no, not reference PCB. That's the Founders Edition. So compared to that, what do I think of the MSI PCB? Well, MSI is certainly saving money on the capacitors compared to Nvidia. Like through-hole polymers like this, and I know they're not in a through-hole package, but like with the plastic adapter plate to make them SMT, these are just cheaper than the flat, like SMD aluminum polymers. The rectangular ones. The cylindrical ones are cheaper than the rectangular ones. Also, this is a through hole? That is really wacky. Wait. Oh, actually, I think I figured it. Wait. Oh, no. That is still really wacky. Yeah, they have a bunch of random through holes. That is wacky. Um, what I mean by that is like you've got two capacitors that are through hole over here. And then you got one up here that's through hole, and it's like, but why? Like everything else on the output is SMT, like surface mount, and then there's just like these three that are through hole, which is just kind of weird. Why? Like, well, whatever. Um, I'm assuming it's some kind of cost optimization, and the reasoning for why that's happening is we have a bunch of what, yeah. So this is going to be display outputs going over to the edge of the board. So that's why they didn't want to have a bunch of through-hole capacitors in this area, because that would make running these traces even more difficult. So that's kind of that. Now, for the actual power stages, we're looking at the same power stages that the Founders Edition uses, but there is how many of them? 16. So marginally more. Yeah, that doesn't make a difference, literally. So instead of the wacky like seven doubled up ones, and what I'm assuming it's 7 with like sharing a PWM signal and one not. This is all of them sharing a PWM signal. So an 8 phase with 16 power stages on it. One thing I do appreciate. Wait, was it MSI? No, I think it was somebody else. But there is a 5080 PCB that actually has labeling for the different voltages. And I also just noticed that MSI actually put a fuse on the PCIe slot. Now, I'm convinced that if MSI could, they'd put a PCIe slot even on like the extra 12 volt inputs. But the problem with the 12 volt high power connector is that that connector handles so much power that putting a fuse on it just stops being practical in terms of like GPU like fuse configurations. Because if you had 3 8-pin power connectors, you would just have like you'd have one fuse for each power connector, and you'd be perfectly good. But with the 12 volt high power connector, you'd need like a 50 or a 60 amp fuse for the entire connector, and that kind of defeats the purpose of having a fuse because it's just not gonna pop before whatever died causes catastrophic damage with all probability. So yeah, that's like another, like, I don't like this connector. I think this is a stupid connector. I don't know why this exists. Like, but you know, Nvidia exists to make power delivery more complicated than it needs to be, or less reliable. Um, but I do appreciate the fact that, like, at least on the one power source where they could have a fuse, they do have a fuse, which is the PCIe slot. Unfortunately, that's not going to protect you from very much because typically, if you have a power stage failure, it's going to be on like vCore or memory, and that's going to just come off the 12 volt high power, and so that fuse isn't going to do anything. But if one of your minor power rails, like I'm assuming this might be PEX, or actually that doesn't really make sense to be PEX, but whatever this over here and that over there is, and like your 5 volt regulator, which like this should be a 5 volt, if one of those fails, that fuse would actually could minimize the amount of damage that gets done by that kind of failure. And then we have another probably 5 volt regulator over here. So yeah, all around, This PCB is just like I'm not very impressed. Like it's not bad. It can handle plenty of power. The capacitors are cheaper. It won't really affect like in from a gaming perspective, it won't really affect anything. Um, but yeah, I'm not like super impressed with this. It's not really anything special, but I do appreciate the fuse. Like that's that's something. It's not like I think it would make like be cool if your $1,000 GPU had fuse it like fused zones for the main power delivery, so that you don't end up in a situation where say a memory power delivery memory power delivery dies and then it cooks all of the memory chips and the memory controller. But this is an Nvidia card, we can't have that anymore. Which is a shame. Actually, you know what? I'll pull up an example of what I'm talking about, because the last time you could actually get an Nvidia GPU with that was the 3090 Ti, and that actually had the meltdown connector, but or but back when the connector first came out, it was actually treated as 3 8-pins in parallel. So you have 3 separate 12-volt regions on this board coming off of that connector. Actually, you have 4 12-volt regions on this board, because you have one 12-volt region coming off of the PCIe slot, and then you have 3 12-volt regions coming off of the 12-volt high power connector. And yeah, so this is cool. If you have a power stage fail on this board, it should blow one of these 20 amp fuses and before it like burns a hole into the PCB. On one of these, that ain't happening because there's no fuse on that connector. So, yeah, that's like one of the like minor downsides, because most other GPU manufacturers can't be bothered to put fuses at all. So, it's just but yeah, I think it would be kind of nice to just have that kind of extra repairability built into the board by just, having some fuses instead of not having them, especially on really high, like really expensive GPUs like this. Um, but yeah. So not super impressed with this. Now then, let's move on to the next one. So Vanguard and the Supreme, kind of the same thing as far as I'm concerned. Like the Vanguard has one less power stage. Like that really doesn't make a difference as far as I'm concerned. Now then, the Astral. Let's see what ASUS did, because they gotta they gotta justify that 50% price increase somehow. And yeah, well, you can't say they skimped on the PCB because they didn't. This looks like it was designed for a 5090. Actually, it might be a 4090. Like this looks like it was designed for a much higher end GPU than it is. Now, what's really cool is, for one thing, ASUS has basically the same amount of respect for the high failure rate connector that I do, so they have a thermal pad to try cool the stupid thing. Then they also have a shunt resistor for every single pin on the connector, which means that this card can actually monitor whether or not the connector is load balanced properly. Which you can't, like, which most cards can, well, actually, literally no other 5080 can do that, as far as I know. And the funny thing is, like, at the price point that these cards are coming out at, like, I don't know why Nvidia doesn't just mandate something like this, so that you can make sure, so that, like, like, you just know for sure that the connector isn't being, like, isn't making poor contact. Because, yeah, each of these just monitors one of the input pins. You can see how they've, like, split up the 12 volt, well, the 12 volts coming in through the pin into its own little separate, like, region. They all join back up together over here, right? And then we have these 2 shunt resistors in parallel, which is kind of wacky, but that's just a consequence of the, this one doesn't use a US 5650. No, this uses the 45492 from On Semiconductor. This is like the same thing as the US 5650, just made by somebody else, because with high-end, well, not with high-end GPUs, but with especially with Nvidia GPUs, because there's so many of them. A lot of components are actually like multi-sourced, where you'll have like two different manufacturers that make NVIDIA compatible voltage controllers, two different manufacturers that make NVIDIA compatible shunt monitors. Because yeah, this does the exact same thing as the US 5650. It used to be that all the NVIDIA cards just used INA 3221s, but they stopped doing that at some point. Speaking of INA 3221s, that is actually exactly what ASUS is using for monitoring that whole set of shunt resistors. Though there's three of them for some reason that I don't understand. Like we have one INA 3221, another one, and these are 3-input shunt monitors. Like each of these can monitor 3 shunt resistors, and there's 6 of them over here. So like I don't know why there's a third one. Because this is enough INA 3221 to monitor 9 shunt resistors. So perhaps there are more, but yeah, no, I can't see any more shunt resistors. So I don't know why there's 3 of those, but there is. Anyway, then we have another shunt resistor down here. This one doesn't have anything extra in front of it because that's just a standard PCIe slot power connection. ASUS is nice enough to label the various power regions, which is cool. 12-volt bus, PEX. So let's see what's over there. Oh, that's this guy. So that's our PEX regulator. Got 1.8 volts, 1.2 volts, MSVDD. Oh boy. Got a lot of different power rails on one of these. So MSVDD, as far as I know, should be something like something similar to Encore on Intel CPUs. But for NVIDIA GPUs. Also, it looks like we got dual BIOS. Yep, we got 2 BIOSes over here. Oh, and they even labeled it quiet and power. Nice. I mean, I guess performance, not power. That's really cool. I appreciate that. I wonder if NVIDIA would give ASUS permission to, like, also add fuses to just make the board a little bit more repairable, potentially, but yeah. Also, here you can see all of the current sensing circuitry coming into the MP28, 29816. And then we have a UP50. Oh, that's going to be the memory power delivery. Yeah, because we got this over here is almost certainly not shunt monitoring, current monitoring inputs for this chip over here from UPI. I really appreciate how neatly laid out ASUS cards are because it makes it really easy to identify different parts of the power delivery. Wait a minute. This might not be an 8-phase controller. This might 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. How many? Wait a minute. Oh, wait. Also, we have MSVDD as a separate power rail. Oh, that makes this a mess. Okay, so we got a memory phase down here. You can see the split in the power plane. Another memory phase over here. You can see the 2 splits in the power plane. Another memory phase up here. So that's our 3 memory phases. And we have our 3 current inputs over here for that chip. Then we have thingy. I'm guessing this is MSVDD down here. This block over here. And then we have a bunch of what I'm assuming is vCore. Then another MSVDD up top. And more MSVDD. Oh, they didn't label everything. Yeah, they labeled the memory power plane. That's not super helpful. I was hoping to figure out, like, what's this and what's this? And also, like, this down here, this is probably MSVDD, I'm guessing? Because, like, the PEX regulator is obviously that, like, very small thing. You don't, like, PEX is not a high current rail. You don't need 50 amp power stages for that. Okay. So this is kind of like 3090-esque in that you have, like, MSVDD, GPU vCore, and, like, MSVDD seems to be quite substantial. I mean, all of this over here could be vCore. Yeah, that's interesting. Also, for memory filtering, we just have some, well, actually, the power filtering on this board is ridiculous, right? Like, so we have the through-hole, like, we have the cylindrical aluminum polymers, we have a whole bunch of those, just 5,000 hours APAC parts, but they're aluminum polymers. They basically don't fail, in my experience, unless you intentionally use them wrong. So that's not really a concern. Like, I have ancient GPUs where the polymers are just fine, and they're not even necessarily rated for 5,000 hours. Because the thing is, these are solid. So they don't have any liquid in them. They don't dry out. They don't burst. They don't leak. They just get slightly higher equivalent series resistance over time. And even that, like, is very negligible unless you abuse them. Like running them at very high temperatures at high load for long periods of time. So, um, like, I guess if you had like a high-end ASUS motherboard, you'd probably get 10,000 hour rated capacitors instead of 5,000 hour rated capacitors. But quite frankly, I don't think it makes a difference. So yeah, like that doesn't matter to me. Um, no, I guess at this price tag, you might be justified in complaining about the fact that ASUS didn't use the same capacitors that they stick onto their motherboards. Though, well, no, the plastic adapter plates, like, I can't I can't imagine that Nichicon would be too upset about having to ship them with some plastic adapters, like. But anyway, so yeah, tons and tons of just cylindrical aluminum polymers for bulk capacitance on the output of, well, everything. And then we also have SMD aluminum polymers because why not? The GPU is extra, like they're charging an extra $500. You got to spend it on something, I guess. So capacitors it is. Um, so the benefit of the like rectangular SMD aluminum polymers is that these have generally much lower equivalent series inductance, and so they're actually better for power filtering, especially in GPU applications. Um, and then we have a bunch of them like scattered around the memory power plane. And also what's cool is that they actually opted to prioritize the ones nearest to the memory chips instead of like this over here and this over here. Because yeah, like the proximity as well with the polymers, like with the SMD polymers, I should say rectangular. The rectangular polymers, the proximity does kind of matter. Not as much as with your multi-layer ceramics, which are like right behind the memory chip itself, but more so than with your cylindrical capacitors, because these have so much equivalent series inductance themselves that where they are on the power plane kind of stops mattering, because sure, you're reducing the equivalent series inductance of the of the power plane, like from the from the capacitor to the GPU core, but the capacitor itself has so much equivalent series inductance that that really doesn't matter very much. Um, so that's why like you always see the cylindrical ones really like you don't really see manufacturers trying to cram the cylindrical ones near anything because yeah, it just kind of doesn't matter. There's some extreme examples on some old GPUs where these are just shoved out of the way for like board, like for heatsink accommodation. But that doesn't happen anymore because GPUs are just gigantic. Um, so there's plenty of space, but yeah, not a priority to like put these in special locations. Uh, we have all our minor voltage regulators up here. Oh, we have some extra fan connectors. That's cool. I like this PCB. I hate the price tag. Oh, and these are using SIC 654s, and those are 50 amps. Yeah, so that's the same thing as the monolithic power systems parts. And we got 20 phases in total, though we don't know what the allocation is, like how much of that goes to MSVDD and how much of that goes to vCore. Yeah, so this is easily my favorite PCB so far, but man, at $1,500, that is not a good, like that, well. Yeah, that's like hard to say. Also, it looks like we have some modification points up here, but Nvidia didn't let ASUS label that because, you know, it's Nvidia. How dare you try to change the core voltage on your GPU? To be fair to Nvidia, changing core voltage on modern GPUs is kind of a lost cause because it doesn't generally do anything. They just don't scale. They're so thermally limited then unless you have them on like a water chiller or something, it's just not gonna. And when I say water chiller, I don't mean like 20 degrees Celsius. I mean like minus degrees Celsius, like below zero, before you're gonna see any substantial amount of like scaling with extra core voltage. Um, so yeah, I'm like the fact like on one hand, I don't like I understand why Nvidia's like, no, you don't get to just change the core voltage directly because yeah, that especially not raise it because on modern GPUs, especially Nvidia ones, that tends to not achieve very much other than drastically increasing power consumption. Um, but it is still a shame that like ASUS can't label the mod points because I kind of doubt most people would dare use those, even if they were labeled. So yeah, actually, speaking of mod points, I'm assuming. Oh yeah, like that's standard. We got our labeled connectors for the I to C interfaces. So if you have like an Elmore EVC2 or something, control like hooking up to this card would be very easy. Now I imagine the MSI board. Yeah, MSI seems to make it also easy. I'm guessing like they didn't label it, right? It's just like J11 and J7 over here. This is probably for RGB programming because it's right next to this thing, which is probably the RGB controller. Um, so I'm gonna guess, yeah, this is probably the VRM controller connection. Because where is that VRM controller? It's right over here. Yeah, so that makes sense. Like it would make sense for this to be the I2C interface of the MP 29816. And I imagine the Elmore EVC2 should have support for that soon, if it doesn't already. Um, oh, also, this uses a 45492 for monitoring the shunt resistors. Oh, and there's also a dual BIOS switch. So, anyway, so far, I really like the ASUS board. Unfortunately, it's also extremely expensive. So let's see if we can find something that I like that isn't ludicrously expensive. Well, yeah, no, this is not it. I do like thermal putty though. I mean, it does make a horrible mess, but like it's cool. Oh, and you know what? The fact that this isn't a bunch of through-hole aluminum polymers, I appreciate that on the output filtering. The input filtering is, but that doesn't really matter. Like the input filtering doesn't need to be like this does the bulk capacitors for input filtering, like they're not dealing with the same kind of transients that the output filtering capacitors are dealing with because these are connected directly to the GPU core, whereas these aren't. So yeah, those don't like I don't really see a point in having really fancy input filtering capacitors. Um, so yeah, that makes sense. And then yeah, the output filtering though, I do kind of wonder if Gigabyte did that more for heatsink compatibility than for anything else. It's also kind of cool that well, I'm not sure how I feel about this. I mean, it doesn't hurt. Like you know, sinking heat from the capacitors, it doesn't really make a lot of sense. Capacitors aren't really a heat generating component. But I guess we're keeping them cooler by literally attaching a heatsink to them. Like it doesn't hurt, I guess. Um, but I kind of doubt it helps very much. Interesting that we also see some of the multi-layer ceramics populated over here that most of the other cards leave out. Um, not a, well, I'm kind of not a fan of the really big ones because these are really susceptible to cracking if the PCB bends. So like, don't bend your GPU, please. Oh, we even have a fuse on the PCIe slot. I like that. I like that a lot. Um, you know, I'm assuming we obviously don't have fuses anywhere else because yeah, we don't. Not that I can see. I mean, it's the 12-volt high power connector. What are you gonna do? It does have dual BIOS. They make the I2C interface for the controller convenient at all. There's our VRM controller. Oh, it's probably this over here. Yeah, I bet this is the I2C interface for the MP28 29816. So that's cool. Memory filtering is pretty standard. So this isn't anything super... I wonder if this would have a measurable difference in terms of like power filtering for the core compared to the MSI card. Because like, yeah, this is a pretty substantial difference in like capacitor configuration. Like that might actually be within the realm of measurable differences. Because there's certain like design choices on PCBs where it's like, there's a lot of ways to kind of end up with the same result, but I do wonder if the Gigabyte board wouldn't actually be maybe better than the MSI board in terms of power filtering. Now, in terms of total current handling capacity, it's a bit weaker. It's actually also a bit weaker than the Founders Edition, though I'm not sure that that's really a problem. Like, one or two power stages really shouldn't make too much of a difference, so I don't really see that as much of a problem. Yeah, I mean, isn't the MSI one like also up there in terms of price point? It's not as bad as ASUS. Oh, okay. Well, 1250. Okay. I'm not sure. If I had oscilloscope measurements, I'd take whichever one runs like it gets better oscilloscope measurements. That's my verdict there. Anyway, let's see what Palit made for the Gainward OC. Man, I remember seeing a Gainward OC, like there was some Gainward OC cards, I think for like 20 series, 30 series. Yeah, it was like 30, 20, 10 series that were really cool. And then they made a 40 series Gainward OC that was a massive disappointment. So let's see what this one is. Oh, I like it. It is weird to see PCBs that look like this. Oh, actually, one thing I forgot to mention with the ASUS card is it's actually, I kind of appreciate, I kind of like the fact that the core and the memory chips, especially the memory chips, are so far away from the PCIe slot. Because that's a really common issue with like modern high-end GPUs that are really heavy, is that the memory chips right next to the PCIe slot break because the PCB bends right where the PCIe slot is, and the memory chips don't really bend very much. They're much more not bendy than the PCB is. So when the PCB bends, the memory chip doesn't, and then the memory chip disconnects itself from the PCB, and then you need to go get the memory chip replaced or reballed at a minimum, which sucks. But by having the memory chips further away from the PCIe slot, that's less likely to happen. So I'm not sure how intentional that is from ASUS that the GPU is further away from the PCIe slot, but it certainly doesn't hurt. Yeah, whereas like MSI, Gigabyte, everybody else just has it just rammed. Well, yeah, it's just kind of rammed right up against the edge. And this board doesn't change anything about that either. Wait, did Palit just take the part, like MSI wrapped the VRM towards this, right? Like we have these two over here. Did Palit just take those and just put them up? I guess yes. Also, I'm guessing this is a 5-volt linear regulator, which is interesting to see instead of the switching regulators. Probably our 1.2 volt rail again. This over here. So that explains why there's so many of these, right? Because on the ASUS card that was labeled that we had like, what was it? 1.8, 1.2. Wait, what's the 1.21? Oh, the 1.21 is kind of substantial. So okay, that might be the 1.8 volt rail instead of whatever else I thought it was. The 1.8 volts is necessary for like the BIOS chip and the memory chips and parts of the GPU. So we got a... Okay, these are all 5,000 hour rated APAC capacitors. You got the random through holes again. Actually, well, no, they are kind of random still, as far as I'm concerned. Um, Apparently, they provisioned for a lot more input filtering than necessary. I'm not gonna judge that without measurements, but yeah, evidently they left out every other capacitor there. You have an RGB header. Don't really care about that. Yeah, I'm not impressed. Oh, and then the memory filtering is all through hole capacitors instead of the SMD aluminum polymers. Hopefully that doesn't make much of a difference. There's no fuse on the PCIe slot either because, yeah. So this is, I mean, the power delivery is substantial. It's just kind of, that's about it, right? Like we've got 16 power stages. It's still the same monolithic power systems controller, but I kind of suspect that for the 5080 and the 5090, this is the only controller that is supported because I haven't seen a different one yet. We still have the MP87993 DR MOS, which are 50 amps. So yeah, I'm not very impressed with this. I mean, it's not bad, but it's also like it doesn't do anything special. It uses the cheapest possible bulk capacitors, and then when they couldn't make the capacitors cheaper, they just left out a bunch of them. Um, right? Like we just don't populate all of them because capacitors cost money. Hopefully, this is at least cheap. Let's find out. It better not be $1,200. Um, anyway, let's see what Colorful came up with. Kind of have high hopes for this one. Oh, and of course the price tag is kind of high too. Yeah, I like it. Um, all SMD aluminum polymers, and oh man, they had. Yeah, I guess they tested this and came to the conclusion either it doesn't do anything or it just costs too much. Though this is doing the input filtering in aluminum polymers, and I am, yeah, like I've mentioned it earlier, I'm not a fan. Like, this just doesn't make sense to me. This is unnecessarily expensive because your through hole capacitors, even with the, like in the SMT adapter, like the cylindrical ones that are adapted for surface mount, those are a lot cheaper than these things are. Also, they're much higher capacitance because if you look at one of these, that's 68, these are 68 microfarads each. Uh, these guys are 270 each. Now, because of the differences in the ESR and ESL, these might actually be comparable in terms of performance, but for input filtering, I think honestly just having more bulk capacitance would probably be just fine. So yeah, I am not a fan of this like I think this is just unnecessary to go all SMD aluminum polymers for input filtering. For output filtering, I'm a big fan. For input filtering, I don't think it's necessary. Um, what else do we have here? So 18 phase. Okay, so one of the more powerful ones. Still the same power stages as everybody else. I mean 18 power stage, not 18 phase. We don't actually know the phase configuration. Um, Oh, right. We've got some vCore, we got some memory filtering, we got more memory filtering, more memory filtering. I kind of appreciate the fact that, like, colorful. Oh, wait, is this colorful? Yeah, this is colorful. That we have these, like, extra bulk capacitors at the far ends of the power plane. I'm not sure how effective that actually is, but it could help, right? The idea being that, like, this memory chip has, like, some extra bulk filtering from over here instead of, instead of not having that, right? So that might help a little bit with the power delivery to that memory chip, though. Without measuring it, I don't know how much that actually helps. So yeah, but it could help. And same thing going on up here. So I do kind of like I like that. That's just a bit of attention to detail in my opinion. But yeah, the input filtering on this is entirely unnecessary as far as I'm concerned. Like this is just I don't know why they bothered. They should have just used the cheaper capacitors instead. It wouldn't make a difference. Actually, if they use the cheaper input, like cheaper capacitors for input filtering, maybe they could have populated this multi-layer ceramic bank over here. Um, though maybe this really doesn't do anything because it might still be too far away from the core or whatever. Um, so yeah, there's no fuses anywhere on this. For hooking up that might be an I to C connector. Or maybe it's just 3 pads all somewhere on the back again. P29, 29816 over there. Oh, we have some labels. 12 volt F, so I'm going to assume F is for the PCIe slot. Ooh, we have MSVDD labeled, NVDD, 5 volt, 5 volt, 3.3 sequencing, 1.2 volts, 1.8. Okay, I like this PCB quite a bit. FBVDDQ, that like frame buffer. Display port power. I was kind of hoping that they would, like, this board would have labeled each instance of MSVDD instead of just one. But the thing is, like, once you have this one labeled, like, if you had the card in hand, you could just use a multimeter to check, like, hey, is this connected over here, or, like, at all, right? Like, it might not be connected to either of those, in which case, yeah, there's only MSVDD over here, and maybe over there. So, oh yeah, and also we have PEX VDD labeled. So yeah, I like this board, except for I don't dislike what they did with the input filter. I just think it's unnecessary, right? Like I'm not saying it's bad. I just think it was kind of pointless. Um, kind of like the 20,000 hour rated capacitors on some motherboards. Very pointless. Um, anyway, let's see what Zotac managed to put together. Now, Zotac cards tend to be a bit brute force in their PCB design sometimes. I kind of like this. Like, very, very first impression. We got SMD polymers. These look like SP caps from Panasonic. I like those. We have a lot of input filtering capacitance. These are 330s instead of the usual 270s. Looks like we have one per power stage, which is kind of the norm. Yeah, like it's usually one per power stage. So this has like like 330s instead of 680s. This has like 5 times the bulk capacitance of that of the colorful card. And also Zotac apparently managed like shoved a bunch of fuses on this. I kind of doubt that this is going to be effective at protecting the card, but hey, like you know what, if it works, great. If it doesn't work, at least they tried. Right? Like better than all the other boards where it's just like, oh, one of your power stages failed. Well, hopefully it doesn't burn a hole in the PCB. I mean, here you still kind of have to hope that all of the fuses pop before the power stage does too much damage, but you know, you might get lucky with that. And we also have a fuse on the PCIe slot, and this one should work just fine because this is just one fuse. So you don't have 3 of them in parallel, which is what's going on over here. Like every single, like these are just 3 fuses in parallel, which is why this is probably not going to work very well. I'm assuming these are 20 amp fuses each. So yeah, that's like 60 amps of fuses for that connector, which is why I'm like, yeah, that's why you don't even like why MSI doesn't bother, because this is like what the 60 amp fuse is gonna pop like when a power stage dies. Yeah, right. Looks like we got a BIOS switch and our 2 BIOS chips. Also a whole bunch of unused pads for extra multilayer ceramics and some used pads for extra multilayer ceramics. This kind of reminds me of like old reference AMD GPU PCBs. in its design. Actually, it reminds me a lot. This looks a lot like HD 7970 reference PCB or a 290X reference PCB because you'd have your through-hole bulk capacitors, which this isn't using, but you can see they have the footprint for them, right? Like for the through-hole bulk capacitors, and they decided to put the SMD polymers over the top of that, which I prefer. But then they also have the rows of multi-layer ceramics in between that, and those aren't fully populated because, yeah, I guess at some point they came to the conclusion that fully populating these doesn't actually achieve any, and like doesn't achieve anything. We also have underfill on the memory chips approaching the PCIe slot, so hopefully that does enough to stop them from breaking solder balls because if it doesn't, this makes repairing the GPU way more difficult. Because now you need to remove the underfill when like reballing the memory chip. So, you know, on one hand, it's like a good thing because it should reduce the probability that the memory chips break. On the other hand, if they do break, you're much like it makes life much more difficult than if there wasn't any underfill. Um, Also, they're only doing it on like this chip, this chip, this chip. Wait, is this underfill? This looks see-through. Usually underfill is like a hard black material, not see-through. Um, I'm not sure. Also, it would go all the way around, not just the edges. Interesting. So maybe this might not be that hard to work with, but I don't know. Um, but yeah, that's like my immediate reaction to that is just like on one hand, this might make the memory chips a lot more resilient to the PCB bending. On the other hand, if they break anyway, life is gonna get worse. I guess it's gonna make repair way more difficult. Um, Anything else noteworthy? I kind of like I like this PCB. Actually, did they do anything cool on the back? Ooh. I like that. I like that a lot. I like it. Oh, yeah. I really. Wait, we have. They even labeled the. Oh, and they did it for the. I mean, this weird. Like, realistically, you could probably solder a connector directly to this. Cool. But what the hell is that? Why cluster them? Just use like your standard header, but okay, fine. Like at least they're labeled. Um I like that. Oh, we also have the extra bulk capacitance at the far end. Wait, did MSI not do that? Oh, MSI has the option to do that, but they decided not to. So I'm assuming this is like a standard feature of the reference PCB design from Nvidia. And then the board partners like either decide to, bother with that or not, and MSI decided not to. But Zotac did, and I'm a fan. I'm a big fan. I like capacitors, and I like capacitors near the things that they're filtering. So, um, yeah, I like this board a lot. This is really cool. Like we have like voltage read points. Like they labeled everything, so that is really cool. Um, there's plenty of room for modding activities if you want to, manually go and populate all of these multi-layer ceramics. I don't think that's going to actually achieve anything, but hey, if you have, spare multi-layer ceramic capacitors or just are incredibly bored, um, that could be fun to mess with, I guess. Um, So yeah, I like this a lot. Also, well, I mean, I haven't really been paying attention to the inductance of the inductors on the cards, so can't really comment on that. Though this is using the same inductors that the reference PCB uses, and like power stages. Yeah, same power stages, same controller. Um, so I really like what Zotac has done. Um, yeah, we have some extra ceramics here. Yeah, I think this is really cool. And wait, the one thing I didn't check is how many phases it has. Oh, this is just a 14 power stage setup. I don't necessarily think that's a problem because the thing with the like how many power stages the GPU has is like, well, it depends how much current the GPU pulls, right? Like it doesn't make sense if you have a GPU that pulls 400 amps, which actually that might be kind of close for a 5080. Uh, 14 phase might be a bit weak for that. Or not weak, but like if it's like 400 at like a reasonable voltage, and then you start pushing it, this might be a bit of an issue. But the thing is, like, the number of phases does not really affect the voltage regulation. That's really more about just how the power plane is designed, what the capacitors used are, how the control loop is set up, um, what inductors are used. So, yeah, I guess, like, I wouldn't, like, I wouldn't want, I'd be maybe a little bit worried about like trying to push this board on liquid nitrogen because the power demands might get kind of out of control. And in which case, the fact that this doesn't have that many power stages might be a bit of an issue. But if you're not pushing crazy power through it, this should have really good voltage regulation performance. Like, obviously, ideally, you'd want to check with an oscilloscope, but I don't have one, so can't do that. Anyway, let's keep going. Gainward. I'm assuming this is just going to be the same board as the Game Rock from Palit. And the answer is no. It is very, like, it looks very similar. But it isn't, and by it looks very similar, oh, they're also doing the thing where input filtering costs too much money. They're not even using high capacitance input filtering capacitors. These are 180s. And they decided to leave out every other one. Okay. I'm not impressed. Yeah, they left this one out. They left that one out. There's just actually they just straight up avoided using any SMD polymers whatsoever. Oh, except this one tantalum over here, which I'm pretty sure is for the RGB, which does not impress me. Is there at least a fuse? Nope, no fuse. Nothing. Okay, I don't like this. This is so far my least favorite PCB we've seen. Because like I'm not like this will run fine. Like Nvidia has very strict rules about what kind of like what kind of PCBs their board partners can make these days. So I'm sure this confirms to the Nvidia spec, but it does not impress me. So yeah, like this will be a perfectly good daily card, but yeah, it's just not impressive. Like they're literally like the wait, what? 270, 270, 270. What? Did they run out of space or did they run out of money? Why are these smaller? This one's tall. Okay, we're gonna actually take a look at what the heatsink looks like, because okay, I'm going with wait. Yeah, no, I'm going with they ran out of money. Because this is straight over here, right? Like this is just a straight piece of metal, which is where those capacitors are. And you got this one. This one's tall. This is an 820. That is a properly tall capacitor. That's a 180. I'm assuming they used a 180 because it was cheaper, not because of clearance issues. Because if there was clearance issues over here, this thing wouldn't fit. Same for this one and that one. These might be clearance. But anyway, yeah, like overall, I am not impressed by this PCB at all. Like they left out every other capacitor. again. And it's not like they, like, this isn't like they had, like, provisions for a lot more of them than usual. This is, like, the standard configuration, and then they still left them out. Okay, so we looked at the Founders Edition. Let's see what Galax cooked up. Oh, and this is apparently supposed to be $1,000. Wait, is this not supposed to be $1,000? This better be 1,000. What? 1150? That's ridiculous. I guess for the heatsink? That's still ridiculous, though. Like, and this is, yeah, but see, these are 270s. And FP caps from Nichicon as well. Like, these aren't from APAC, so these are probably a bit more expensive. Because Nichicon is a, like, Japanese brand, whereas APAC is a Taiwanese brand. It doesn't actually matter, but in terms of cost, right? Like, these, as far as I know, are probably more expensive than the APAC options, even though for, like, reliability and performance that you wouldn't be able to measure a difference as far as I'm concerned. For aluminum polymers, it just kind of doesn't matter who makes them that much. Because the just type of capacitor that they are inherently is very resilient, so right. But yeah. So like if Galax can squeeze a PCB like this into the like $1,000 MSRP, I don't see how this is supposed to be more than more than $1,000. Like this literally has less capacitors, probably cheaper capacitors than what Galax is using. Less power stages, I think, or same. No, this is apparently 14 power stages instead of 16. So, yeah, wait, really? It doesn't look like there's a difference. I'm going to have to count these. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm pretty sure this is 15 also. Because, like, you got a memory one over here, oh, wait, no, because memory, core, input filter. Okay, so, yeah, so this is 14. Wait, so how is... 1, 2... Oh, because they crammed them all the way to the bottom. Wait, no, that's the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, okay, I see it. Memory, and then 1, 2, 1, 2, right? Yeah, so 16. Okay, cool. Yeah, so this is just better. Though, I guess, no dual BIOS switch. There's only one BIOS chip, I think. It looks like. Yep, just one BIOS chip, because there's not even another, like, there's no extra BIOS chip on the back. We do have labeling again, 1.2 volts, MSVDD, PEX. If you're wondering where that PEX is coming from, it's over here, which is wild. They're running it under the vCore VRM. Shows you how low power a rail it is that they can just shove it all the way by the display connectors and then run it under the vCore power stages. Like, this has to go under... like, this is squeezing through, like, display connection... Like, display signals, right, are running into this area. This has to squeeze under the 12 volts, the control signals for the power stages, under the vCore power plate, and then to the GPU. So yeah, I mean, it is kind of going literally under. It might actually be on one layer. The PEX rail. It might all be this one polygon over here. But anyway, so that's PEX. So yeah, this is labeled, which is cool. It's powerful. They labeled the, well, yeah, I guess GDDR, DDR counts. 1.8 volts is labeled. GPU is labeled. It's just a bit hard to find. So I kind of like, as a budget option, I like this PCB. Like, if they reach that, like, if the price point for this is real and compared to the other cards, then like this This makes sense. I like it. Cool. Is that all of them? Okay, that is all of them. So, highlights. Galax, Zotac. Where's the ASUS board? There, ASUS board. Oh, I guess I kind of like the Gigabyte board as well. Eh. No, I do. I kind of like they're not cutting corners on like input filtering or output filtering. I mean, they didn't populate the far. Well, they populated one of them with one of those giant multi-layer ceramics. So yeah, I do kind of like the Gigabyte board. You know, these two over here, right next to the PCIe slot and that screw hole, that is a cracking hazard. It should be fine, but like, yeah, multi-layer ceramics in close proximity to screw holes and especially the piece like a big multi-layer ceramics are just like, because they're very rigid compared to the PCB. They really don't bend. So when the board bends, these break. And that's actually kind of a pretty spectacular failure for like how like it's just like a mechanical damage, but these like when these crack, like they tend to burn up quite spectacularly. It's not actually a big deal in terms of affecting the functionality of the GPU though. So yeah. So obviously my favorite PCB is the Asus one. Unfortunately, it's also extremely expensive. Then I kind of like the Galax board. I like the Zotac board. I'm not sure which one I would rank higher. Like this one has slightly more power handling capacity. This one has better capacitors. Also fuses. Okay, I actually like the Zotac board more. And then we've got like Galax and Gigabyte, and between these two, I guess Gigabyte ahead slightly. Yeah. Or maybe the Galax one? Wait, this one also had... No, this one doesn't have all the labeling. That was the Zotac board where they labeled everything. Yeah, that was Zotac that labeled everything. Yeah. So that's my thoughts on the 5080 PCBs. Also, this video is an hour long, which was not my plan at all. Anyway, hopefully you found this somewhat interesting, if not particularly useful. Thanks for watching. If you'd like to support the channel, there are links in the description. And that's it for the video. So I guess thanks for watching and goodbye.